afternoon and welcome back to my channel. I know it's a while since I've posted anything. There's been a slight issue of the four horsemen of the apocalypse descending down upon us over the last year, as I'm sure most of you know. However, hopefully the time spent has not been entirely in vain. Today I've got something slightly different to what I've usually done. Today we're going to look at what is to me anyway, a useless piece of equipment. Obviously to many people they rely on it all the time. And we're going to take it apart and we're going to find out how it works. And we're also going to look at what it is and why it works. Here today we're in my newly reconditioned garage, which was one of my lockdown projects. So we'll be able to make use of the new workbench. Now, what is this machine that we're looking at? Okay, as you can see through the wonder of modern editing, I have a Henry Hoover which is attached to something. If I can go off on a rant for a second, Henry Hoovers are by far the best Hoovers ever made, and unlike that Pillock Dyson, they're actually made in the UK. They've been making the same Hoover since 1980 and you can still buy all the spare parts. I myself have had this Henry Hoover for pushing 15 years now. Anyway, that being said, why am I using a Henry Hoover? Well, they're good for sucking, that's why. Henry Hoover is connected via this pipe to this little black device here. You'll notice that this little black device, if you recognise it, isn't quite complete and is missing this part. I'll go into that later. This little black device is a very, very old vacuum-powered artificial horizon, or attitude indicator, as they are sometimes known.
Человека космическое пространство.
I believe that this one is from an RAF trainer known as a Jet Provost. This was a class of aircraft built in the 50s and 60s. Over 400 of them were produced. I can't verify its origin. It seems to me that it might actually be slightly older than that, and we will get into some of the theories as to why I think that below. However, the Jet Provost served until relatively recently, certainly the 80s, so there may be some of my viewers who may even have flown with one and can go, oh yeah, Ollie, that's definitely what it is. What is an artificial horizon or attitude indicator, and why do you need it? As you know, in an aircraft, you do banks and turns and up and down. Now, usually you can look out of the window of the aircraft and you'll see in front of you, stretched out below the horizon. That horizon tells you the attitude or angle of your aircraft to the ground. Now, we all know the ground isn't flat, it's a sphere. However, for the purposes of an aircraft, the ground is essentially flat in this particular instance. Now, usually you use your eyes, you look at the horizon, you fly your plane. What if there's bad weather? What if it's dark? What if your windscreen is covered in shite because a bird smashed into it and you can't see out of it? There could be any number of instances where you're unable to see that real horizon on Earth. For that reason, all aircraft today are fitted with a device such as this, albeit in much more sophisticated form nowadays, known as an artificial horizon or attitude indicator. What that does is it gives you a constant indication via a line that moves up and down and rolls, which we will hopefully see if we get this thing to work, of the actual horizon. But you don't see the actual horizon, you see the artificial horizon. I know what you're thinking, that's just a plumb bob, isn't it? If I'm building and I hang a plumb bob, a weight at the end of a piece of string, that's always going to tell me where down is. You are somewhat correct. Unfortunately, however, as you know, aircraft fly quite fast and quite high. And when you go around a corner, you won't sense that you're going around a corner on an aircraft if the pilot is banking it properly. You might, if you're very good, detect a slight bit of extra acceleration, because what the pilot is doing is he's banking the aircraft so that the effective force angle, which is gravity combined with the centripetal force from the turn, lines up with the floor of the aircraft. In other words, if you hang a plumb bob on an aeroplane and you fly the aeroplane correctly, the plumb bob is only going to indicate where the floor of the aeroplane is. Well, you know that, your feet are on it. What an artificial horizon does is it maintains a fixed reference plane with respect to the horizon. And it does that by a system of gyroscopes. This particular artificial horizon, and the reason that I bought this one as opposed to the many other more modern ones that were in the artificial horizon shop, is because it's old-fashioned and it uses a vacuum. A lot of the more modern ones are electric and are better for many ways. However, the shop didn't have any documentation on any of these, and frankly, I figured I'd have a much better chance of getting an electric one going than, pardon me, I figured I'd have a much better chance of getting a vacuum one going than an electric one going. Now, when I bought this device some days ago, I went round to my friend Ollie's house and we dismantled it and we figured out how it worked. In doing so, we had to remove this faceplate, and I'll show you why in a minute. Ollie's vacuum was not working. That's a long story. So it wasn't until I got back to my house that I could connect this to a vacuum and spin it up. Now, I can hear from the fact that it is spinning inside that it is spun up, but it's not aligning itself. And the reason it's not aligning itself, I hope and suspect, is because it's slightly out of balance because I've removed the faceplate. So, unfortunately, what I'm going to have to do is disassemble this whole thing again, and in so doing, I'll show you how it works. Reattach everything, reattach the faceplate, put it back together again, and then, hopefully, if we spin it up, it should work. If that doesn't happen, well, I'll have told you the principles, won't I? I guess that's just engineering. Anyway, stick with us and let's find out. Right, so this artificial horizon, it weighs about 2-3 kilos, I think. It's been ripped from the cockpit of a plane, allegedly, as I said, a Jet Provost, and it consists of a machined metal cylinder. I'm assuming it's aluminium, but I'm not sure about that. At the back, you can see an air filter here, and then we've got an exit point here, which I've used high-tech gaffer tape and cable ties to join this hose that I happen to have. In fact, this is the very same hose you saw me use in my surprisingly popular oil change video on Honda Civics. What actually happens is the air is sucked out through this pipe by our friend Henry, and therefore it comes in through this filter, and behind that there's a finer filter. The movement of air through the device spins a turbine inside, which spins a gyroscope, which should ideally balance the reference line. Now, at the bottom there's a little screw, and I'll show you what that screw does as we take it apart. I'm a bit confused, and Ollie also had some good theories about this, but that screw, if you screw it in, it locks the gyro, and I'll show you how that happens. However, to unlock the gyro as it is now, you need to unscrew it. But then that screw, as you can probably see, is a bit rattly and a bit loose. And I find it hard to believe that they flew around with this screw just undone like that. So it's possible that it was maybe completely removed and then plugged. Honestly, I don't know. On a lot of other horizons that I've seen, there's other options as well. There's generally a knob on the front of it to cage it, which essentially does what that screw does. So it effectively locks the gyro in position. So for example, if you're going to do some heavy maneuvers beyond the range at which the horizon works, you can cage it before. Also, often they'll have some kind of light dimmer switch on them. So again, this neither glows in the dark nor does it have a light on it or any electrical input at all. So I suspect that it was certified only for day. There doesn't appear to be a manufacturer's number on it, although there is a part number on it of some kind, or a serial number of some kind scrawled on it. It's not clear to me when it was manufactured, but the last date that it was lubricated was 1975, so there's a good chance that Ollie and I, when we took it apart for the first time the other day, were the first people to go in here for more than 40 years. It does have handle-like eggs printed on it. Again, I'm unclear why, because I think it's a substantial construction, as we'll see in a minute. We had to scrape the paint off the mounting screws, which hold the front and the back on. And unfortunately, it's the devil's work. Everything is using slotted screws. First thing I'm going to do is turn it upside down and remove the slotted screws at the back, of which there's 1, 2, 3, 4, 5, 6. That will allow the back plate to come off. Let's do that first. Okay, a rather key lesson learned there, which is when you're dismantling a machine on camera, make sure you've pressed the record button, because I have just lost the footage. But basically it wasn't that exciting. What I've done is I've taken these 6 screws, all slotted screws, off the back housing here, which will enable me to remove the back housing from the device. The trick that Ollie taught me was put the screws in a chewing gum bottle, such as this, and you'll notice if I pull these screws out and hold it up to the camera and try and focus in a meaningful way, they are cheese head screws, and each screw has a little split washer on them. Now they're also magnetic because they stick to my screwdriver, just about. And so they're obviously not brass or anything like that, but they are cheese head, except one, which is a countersink, and that countersunk one had a special recess in the casing, and I think that's either for alignment or security, I'm not sure. Once you have all those screws removed, you can simply remove the back plate like that. Now, let's take a look at this back plate. What we'll see here is, we can see if we zoom right in here, and hopefully there's enough light here, you can see a ball bearing here, and behind the ball bearing you can see what looks to be a white plate, and I'll never have the resolution on this camera, but that white plate is a very, very fine air filter. What that means is that air can be sucked in through this coarse filter, through the fine filter in the middle of that ball bearing, and into the device. It then goes through the device and it comes out this evacuation part here. So the spindle, if you like, that sits inside that bearing is this spindle here, and as you can see, that spindle here consists of a nozzle which sits inside the bearing. That's the part that runs inside the bearing, and then these small holes in the main axle of that shaft which allow air to enter. Now, what I originally thought with Ollie when we took this apart the first time is that you'd simply take the back plate off, as we've done, and then the whole assembly would simply withdraw. Unfortunately, that's not the case, because the front plate of this assembly locks it in place in such a way that it cannot simply be withdrawn. I've already removed this front plate, and I'll show you how. Therefore, it is extremely simple now, with a little bit of manipulation, to withdraw this assembly. But you'll notice that there's an extra slot here in the case. That extra slot has to line up with one of the bosses on a gyro assembly, which you'll see in a second. And if I carefully withdraw it, and it is a fairly tight fit, as you can see, but it's probably only designed to be taken out once or twice during its lifetime, we can withdraw the whole gyro assembly. At which point we can also see that, thanks to my ham-handedness, the bearings at the other end of the gyro assembly have come loose. This is the gyro assembly, and we're going to talk about how it works just as soon as I press pause and try and reassemble this bearing for the nth time. If we look at the main casing again, we can see that it appears to be a casting of some kind, and at the end there is a support boss here, which we can see. That support boss has a shaft on it, which lines up with a bearing on the end of the gyro assembly, which is this bearing here, which would have balls in it, but they've fallen out. Take it from me, it does. Now, if we look at this on the front, we can see that this support shaft here is actually at 90 degrees to the main angle. So this is horizontal here, so the support shaft is at 90 degrees. Now, you'll also notice, you can probably just about see, if I try and hold this steady and then focus again. Unfortunately, there's reflections everywhere. Let's try it that way. You can also see that the shaft itself has a gap between it and the glass plate on the front of the device. That gap is the space where this faceplate goes, and actually this faceplate goes like this, because this faceplate indicates the global down direction. Now, that faceplate is usually attached to the gyro assembly via these two screws here. These two obviously flat-headed screws at the front end. Meaning that when the faceplate is attached like that. The wiper assembly here moves up and down across the faceplate, but you'll notice that there's a gap between the faceplate and the bearing, meaning I cannot insert the whole thing this way into the bearing because the faceplate blocks it. What that means is that you have to take the front off the artificial horizon and then manipulate, in a way that I haven't yet found out, to be honest, how to do, these two screws here, which are, as we'll see, behind the barrel, somehow using a 90-degree screwdriver, tighten it with those two screws. Now, I managed to loosen these two screws. It wasn't easy, but I had to use essentially a razor blade and slide it in from the front to loosen them, and then a pair of pliers. So that is why I wasn't in a hurry to put the faceplate back in again. And I think what I might do is temporarily fix it with tape. Now, the reason that I think it's not working properly without the faceplate is that this assembly is balanced, or should be balanced, and that faceplate is a key part of that balance system. Let's look at how this thing works. Okay, so we're generally familiar with the principle of a gyroscope operation. Inside this gimbal assembly here, which we will see once we take it apart, there is a turbine. Now, that turbine is spun because air enters here through these holes. It travels around this arm. In fact, if we turn this over, you can see that this arm actually had at one point a slot milled in it. And then that slot was filled in with what looks to be epoxy. So underneath that epoxy, there is an air slot, and that goes into this boss assembly here. In there, there's a similar arrangement to this bearing, which then allows air to enter this central chamber here, spinning a turbine inside there, and then coming out via this assembly here. Now, you will notice that this assembly is by far the most complex part. So it has these little shutters on it, 2 sets. And these somewhat fumbled Ollie and I when we first came across them. And it was Ollie Jackson, who in real life is an A320 pilot, who figured it out. And he pointed out that the way gyroscopes work is gyroscopes generally don't want to be moved. So because a gyroscope is nothing more than a spinning weight on a gimbal, the spinning weight inside this gimbal wants to remain in that plane, no matter where it is, okay? So it wants to stay like that as the plane moves around it. But it can't, because we live in an imperfect world, both from a thermodynamic and, frankly, let's face it, human intellect point of view. These bearings have friction in them. Especially now I've coated them in a fine mix of blue tack and WD-40. What that means is that the spinning weight in here imparts a torque onto this device, and usually, because it's gyroscopes and gyroscopes do funny things, that torque's at 90 degrees to the actual direction. But notwithstanding that, it will make this gyroscope want to move as it turns, and that wanting to move due to friction in the system initiating forces is known as gyroscopic precession. So gyroscopic precession. Now, if that was uncountered, it would result in this thing locking up and moving to the maximum limit of its operation and staying there in a given amount of time, depending on how much friction there was on the system. What these weights do is they allow this device to normally sort of sit vertically like that. And because this device is operated by air, the air has to come out of these little holes, which are covered by these little shutters. And so the entire central barrel is a vacuum chamber, and the only way that the air can come out is through here. Well, that's a bit like a jet, isn't it? So air coming out of these holes is going to impart a force onto this gimbal. And depending on which one of these shutters is open will depend on the magnitude and direction of that force. Now, the two shutters are ganged together on 90-degree sides, so that one's ganged and that one's ganged. What I think happens is that this is a self-aligning feature, so that when you turn the gyroscope on, this device wants to be vertical, just due to gravity. So we're sitting on the ground on the runway. It wants to be vertical, and it's slightly balanced that way. These shutters are operated by gravity, whichever the local gravity is, meaning that they will slowly, under a feedback system, open and close until this device is vertical, at which point the gyroscope will be aligned. Now, because this device does not have a full range of movement, there's going to be some aerobatic maneuvers which is going to result in this thing locking up. If that happens, I suspect that when the plane returns to level flight, these shutters will, after a few minutes, hopefully realign the gyroscope system. So let's take a slightly closer look at this. So the first thing that we notice if I hold the gimbal like so, is that as the central gyro moves up and down, the mechanism here adjusts this balanced wiper arm. And that arm is what tells us whether the plane is pitching or climbing. Diving or climbing, pardon me. This arm is what's telling us if the plane is diving or climbing. So normally it would sit in there like that in the glass, and that moves up and down to indicate whether the plane is diving or climbing. Because the whole device can roll inside the barrel on these bearings, and that will be connected to the faceplate underneath like so, and the housing will maintain steady course whilst the faceplate and the little marker below it moves with the wiper assembly. That indicates whether we are rolling. So this wiper indicates climbing and diving. This wiper indicates climbing and diving, and the orientation of the faceplate with respect to the marks on the barrel indicate roll. If I remove this faceplate here with these 3 screws on it, which I have already done, but I will now do a second time. Obviously, through the magic of video editing, we will speed up through a lot of this. And you do need the hands of a child. So if any of you have such a thing as a child, they may be able to assist you in this work. Let's face it, the younger you can show children the true cause of engineering, the better. I know I certainly benefited from it. We'll edit that bit out. Okay, so now we have the 3 screws off, and this faceplate should gently come out, except of course I now remember that it doesn't. It needs to be persuaded, and the reason it needs to be persuaded is because it's actually inserted in, which will become apparent in a second. And yes, I know the designers of this did not intend me to start shoving screwdrivers into it, but let's face it, this thing is long past its flying days. So that draws this out, and I've just destroyed a washer, I notice. Well done, Ollie. Ugh, vandalism, isn't it? There is no force as powerful as ignorance. Right, we can now see that this whole assembly here has a slot in it, and that slot has to be aligned with the gap, the gap here that we see that is in the actual arm of the machine. So you can see that the air is coming along this arm of the machine and out that gap there. When it comes out of that gap, it goes into this slot in this bearing housing boss and through into the central arm. You can also see that just as before, there's a bearing at the end of here. If I put that to one side and we take a look at what we actually see here, you can see exactly the same system as we had before. You can see some holes with a riding axle on them, just like we had at this end. So now you can see that the air is coming through this rotating part, round here, and into this rotating part. We can now start to look at how to get the rotor out. I believe it's possible to remove this whole central housing by playing around over here with this screw fixing, but I'm not that bothered about it and I don't need to do it, so I'm not going to do it. I also have to remember how to get the rotor out, which, as far as I remember, is you turn it up this way and then you undo these 3 springs. These, by the way, appear to be bump springs to allow the gyro to hit its stops without coming to a sudden jarring stop. So, let's take these 3 screws off. Normally, I'd love to say I take better care of machinery than this, but I would be lying. I take a fairly Russian approach to my machinery. If it can't take the pace, then it ain't the machinery for me. I like the sort of equipment that you can hit with hammers. Interestingly, one of the best pieces of equipment that I ever owned was a Czech angle grinder, and lasted me for many years until I left it at my folks' house and never saw it again. That's why you watch this channel, isn't it? For my exciting anecdotes. Okay. This should now simply withdraw. Dun dun dun. Like so. Now, you'll notice that this thing has been quite finely balanced and there's holes in it which are presumably drilled for balance. You will also notice that this component here is the rotating gyroscope. Appears to have been individually made because there's small holes drilled in it to balance it out. That device simply removes like this, and then at the bottom we see a series of holes here to allow air to exit. Don't forget that exit is going to be via this flow control mechanism here, and another bearing. The turbine itself is a fairly straightforward notched piece of brass where they appear to have driven a mill head into it and then rotated it with a dividing head and repeated. This, I think, is the finest British engineering you'll ever see. Such technology, a milling machine with a dividing head. Will wonders never cease? Appears to have an axle. I assume the axle goes all the way through as some kind of push fit. That allows it to sit in the, what I'm going to call the volute chamber. I'm sure that's not the technical term, but I'm making an unscripted low budget video here, so I'm sure one of you can tell me what it is, which has got these machined faces in it to allow the air to flow. Notice that you have a number of slots in this part here. Now, as you remember, the air is coming in here and then it's entering this casing here. So it's still not inside the actual turbine area. To get into the turbine area, it has to come into these 2 slots here and then out these holes here. So there's one hole there and there's one hole there, and they are at an angle which is forcing the air to go anti-clockwise as we look at it. And as you can see, the way that the turbine has been made, it wants to receive air in an anti-clockwise direction. So when air flows in there, this should move in an anti-clockwise direction. So air enters this gimbal here via the holes in this gimbal shaft, goes round this milled slot coated in araldite and comes out of this slot here into this bearing assembly, which is normally here, which then allows air to enter via a second holed shaft assembly into another milled out aluminium disc with angled jet holes in it, 2 of. Those jets impinge upon the, let's call them blades, on this heavy rotor, which spins and then the air leaves via these holes at the bottom of the gimbal assembly and out through these servo shutter assemblies here at the bottom. That is all there is to it. So in terms of its end mechanical design, not too complex, but there will have been a lot of maths involved in this that I shudder to think about. There are various adjustment screws in here as well. I believe that this device here at the top, I think, is I'm not entirely convinced what it's for, but I know what it does. There's a cone inside here which drops down when a device is completely inverted, and I think that that somehow channels air to convince it to not do anything until it's righted again, because if the device is completely inverted at the end of it stops, it would want to right in the same direction as the stops. So I think that's an anti-inversion device that's in there. I'm not sure though, maybe one of the viewers can correct me on that. As a side note, when putting this back together, it is very important to align all the slots so that the air can actually get where it's supposed to be going. There is a right way round for everything, and I have relied on photos to do that. One other thing I want to show you before I put it together is at the beginning I mentioned this screw here, which is a caging screw. Now what that screw does is it impinges on this leaf spring assembly inside the barrel. So if I tighten the screw, you'll see that leaf moves out. And a hole at the bottom of that leaf there meshes with the lug at the bottom of the gyro and locks the whole thing in place. Now again, I think that that is a transport option, and I do not believe that this screw here should be left in the loosened position as is, because it could just come out and fall into the cockpit. But equally, if you remove the screw completely, there's a small hole in the barrel which is going to reduce the efficiency of the vacuum. So I'm not sure what the arrangement for that was. There didn't appear to be a manufacturer's name on this, so I'm really unclear. Finally, before we magically cut to a fully assembled piece of equipment, I should state that to assemble it, I'm going to have to take the faceplate off the front, shove the entire gyro assembly in, and then somehow, using the hands of not merely a child but a highly trained gibbon, reattach this faceplate. So I have reassembled the main gimbal assembly by replacing the bearing and the housing for the turbine, and then what I'm going to do next is remove the faceplate for the main barrel. This just consists of 8 screws, so it's fairly straightforward. Again, I had concerns about these screws, but the manufacturers appeared to have done a very good job, and something that I don't see very often, I have to admit, of not over torquing the screws. So although one of them was a bit squeaky bum in terms of getting it off, I did manage to get all the screws out without destroying the abysmal design feature that is a slotted head. And frankly, anyone who uses slotted head screws deserves to be dressed up in sexy lingerie and deposited in Kabul outside the household of a well-known Taliban organisation, because they are the work of the Dark Lord Sauron, and there is just no excuse whatsoever for slotted screws. Honestly, I have more time for people who vote for Boris Johnson than I have for people who use slotted screws. Once the screws are out, this device does come off. Remember that the mark at the bottom here goes in this orientation with respect to this device, because it is of course possible you could put it on like that, which we don't want. So it's important to get the orientation right. Removing this, we can see the other end of the arm, and we can see that the lid itself is quite heavily manufactured. It consists of an aluminium plate, like a solid aluminium plate that represents the dial on the front. So it's quite well manufactured. Now I have to unscrew up the horror that is the bearings, the ball bearings that go on the end of this device here. But once I've done that, I'll be able to shove this whole device in like that and then attempt to reaffix the faceplate. Right, so we've got our barrel here and we've got our gyro assembly here. As we remember from the barrel, the orientation is thus. Now, we also know that the gyro assembly will only fit in a certain way. So actually to get these together, it's not that hard. I'll skip through it, some of it in editing. We're going to insert the... I swear to God, this bearing at the front just keeps exploding. So the faceplate here keeps popping off, and every time it pops off, the balls drop out. So hence why I'm going to edit some of this. So assuming you've got your bearings sorted out again, and as unfortunately in the last time it exploded, this bearing's dropped one of its balls and I can't find it. So now this thing, even if it does work, it's not going to work properly. I will try and get a replacement at some point. But the general principle is, holding your machine thusly, you align this boss here with the slot at the bottom of the barrel and gently insert it. And I'm going to try and maintain it. Then I've got to slide the wiper past and insert into the barrel like that. Now at this point, what I'm personally going to do is turn it upside down and put the back plate back on to try and secure it before I try and put the faceplate back on. Because if I put the faceplate back on here, even if I manage to get it in place and screw it in place, it's only going to take a second for everything to fall apart, and then I'm going to have a miserable time. So let's not do that. So I've put the 6 screws back into the back plate, and now I'm just going to tighten them. Not too much, just enough to hold it in place. As I say, I'm a bit annoyed with myself for losing that ball from the front bearing. I'm going to have to do like a magnetic sweep of my garage floor to find it, because it's disappeared under the workbench. So when it exploded, I just heard a ting as one of the balls dropped out and presumably ran across my garage floor. And when I came to count them, I realised that instead of the full complement, I was missing one. So having lost a ball, I was somewhat disappointed. But before all you ladies start saying, oh well, what's the point of living, you can take some courage in the fact that it was a ball bearing and not a testicle. I have to explain these jokes for some of our American audiences. Right, I now have the back in base, and as you can see, it rattles like arse because there's not the right number of balls in there, but it probably will just about manage to spin if we're lucky. Like, you know, if we're really lucky, bearing in mind it's going to sit this way up. So usually it's going to sit this way up, so that should at least be able to spin. So it's not going to be perfect, but the principles should still work. Now hopefully you can see what I meant when I said that the faceplate has to go back in there and then onto those screws there. But of course I can't get at those 2 screws with a screwdriver because they're behind the barrel. So this is where our highly trained Gibbon comes in. To be clear, I'm not even going to attempt to do this bit on camera because it's going to involve way too much swearing for even the most robust of my viewers. Honestly, there's got to be a better way of doing this, but I have not yet figured it out. I frankly think it's a miracle I've managed to tease 1 screw in. I've still no idea how I'm going to tighten the little bugger, and I've got the second one to go. But yeah, this accidental 2 screwdriver method of basically just trying to roll the screw in
does seem to be somewhat successful. And frankly, we don't need it super tight because let's face it, this thing ain't going to work properly without that bearing. And these screws aren't going to need to stay in position long. So just to prove that I have done it, there is screw number 1 in place. I'll somehow need to tighten it and then we'll try screw number 2. Right, I've somehow teased the faceplate back in, and as you can see the whole thing rotates like this and like this, but it doesn't rotate very well because of that dodgy bearing, so I'm really not holding up any hopes of being able to show you very much interesting, but we'll give it a go. Next we're going to put the faceplate back on again, the frontispiece, and as you can see with the frontispiece on, you can see what should be able to happen is that this line here, which as I say is the wiper, moves up and down like that. So that will indicate by reference to its position relative to this fixed line whether you're climbing or diving, and its angle will indicate your roll. As I said, remember to put these things on the right place. The eagle eyes amongst you will realise the faceplate is 180 degrees out. Now, again, something I've seen on more modern ones is there's a little turn screw which allows you to move this fixed indicator up and down slightly, and the purpose of that is to allow you to account for the parallax between the distance between the wiper line and the fixed line. So if you're taller or shorter and you sit at a slightly different height. Again, this device hasn't got that, but I suspect for the purpose for which this device was intended, i.e. a training plane, that's probably not a big deal. And of course we just put the 8 screws back in and give them a tighten. Now in a perfect world the joints on the front plate and the back plate are gonna maintain a vacuum, because of course the less air that can impinge on this device from the outside, the more air has to be sort of forced through the internal working mechanism. There didn't appear to be any sort of rubber gasket or anything in there, so I suspect that that vacuum seal is really just achieved by use of machined surfaces on the plates. As you notice, I've just dropped a screw on the floor, so I will have to pick that up. If I was a more serious YouTuber, I might refilm this, but I'm not, so deal with it. If you want high production values, all I can advise is that you go and watch another channel. But then, of course, you wouldn't get the benefit of witty banter with Ollie Epsom. And here's the screw. Let's put the last screw in. Let's screw it in tight. Oh, that's exciting, isn't it? As long as I don't end up on some obscure ASMR playlist at some point. That really would add insult to every single injury I've ever received in my life, which I think, as we've established, is many of them. Now, in principle, we now have an assembled unit, and we can fire up the vacuum and spin it up. Now, I know the last time I did it, I knew it was spinning up because I could hear it, but it didn't seem to want to balance, and I think that was because of the weight distribution. Now I've fixed the weight distribution problem, but I've got a bearing problem, so I suspect we're not going to be in much more success, but let's give it a go anyway. So if you put your head right against it, you can actually hear the gyro rolling. Now, first thing I've noticed is I've bent the wiper a bit, so the wiper's getting stuck, but it does seem to be a lot more successful than I thought. So I'm going to take the faceplate off again, bend the wiper back in place, and see what we can do. I'm also going to try and put your microphone right up to it to see if you can actually hear it, but I don't think you will, because it makes a really nice sound. Okay, so now I've put this in its orientation that it's going to be, so this is the way that it should be up. As I say, if I just remove the unscrewed front plate off, you got the wiper assembly here and the indicator. Now what I'm going to do is I'm going to spin it up using my Henry Hoover, and then I'm going to turn the Hoover off, and then I'll demonstrate whether it works and what precession is, because we're seeing a lot more precession than you would expect because of the dodgy bearings. So let's spin her up. You can probably hear it running now. I've disconnected the vacuum, but it'll keep spinning. If I then remove the faceplate, which I can because it's no longer under a vacuum, I can sort of force this wiper into position. Now you'll notice that if I then rotate this, that wiper wants to go 90 degrees to my movement, and that's because of gyroscopic precession. Likewise, if I try and adjust the wiper, it wants to roll and pitch the main one. So just by putting a force right in the center of the wiper, so not a rotational torque force on it, it wants to rotate the main gimbal by 90 degrees. See that? And unfortunately, because the main bearing on this is knackered, because I've lost a ball, there appears to be an ongoing problem with pitch stability. So if I zero it there, which of course you can't do on a normal device, and pop the faceplate back on, and then turn the vacuum on again, I don't think it's going to stay zeroed, but let's find out. You'll notice that it does actually work quite well, but when it goes out of alignment, that is because... We'll cut that out. Once I've got it aligned and it's still spinning, it does work. I wouldn't want to rely on it, but what's happening here is that internal mechanism, because it's dropped, because the internal mechanism is lower because there's a ball missing, is contacting that internal spring, and it's forcing it out of alignment, which is most annoying. So if I then set it up for where it should be, it will work, and you can see the diving and pitching is indicated in the roll. Now obviously it's slowing down at the moment, so it's working less well. So if I knock on the vacuum again and spin it up again, we'll see how well it does. So now with the vacuum on, the internal mechanism is spinning up, which I can hear. You can't probably hear it, but I can hear it. I can also hear it by putting a screwdriver on it and listening old school Das Boot style. Sounds a bit like a DC motor spooling up. Now with this, you'll see it works quite well. But as soon as I get to a certain place, it goes out of alignment, which is not what we want. So in summary, I think what we've got is a qualified success, because it actually does function as it's intended to function, with the exception that, due to my own incompetence and having lost a ball from the bearing assembly, it doesn't work right. And the reason it didn't work well in the first place, when I first turned it, was because of the out of balance effect caused by the lack of the faceplate.
Okay, so with this thing spinning down in the background, that comes to the end of our video. So what we did, we took apart an artificial horizon and figured out how the gyroscope works. Now, what I am going to try and do in the near future is find a replacement bearing for that, or even just a ball. I'm sure they're in Freedom units, but I'm equally sure that even here in the barren wastelands of Scotland, I can buy an Imperial ball. There are other videos that I'd like to make in future. Behind me, off camera, there's a new toy of mine, which is an electric scooter, Super Soco CPX, does about 90 kilometers an hour. Runs on a 62 volt system, and I've managed to fit heated grips to it, which obviously run on a 12 volt system. So at some point I want to make a video about how I did that. I've also got one on 3 Mile Island in the works, but it really does depend on time and energy. But notwithstanding the above, thank you very much for watching, enjoy the rest of your day, and we'll catch you on the flip side.